Hi, how's everyone going? Okay, quick poll. Who went to React Sydney a few weeks ago? All right, you should all leave. I'm giving the same talk, basically. I'm sorry. For everyone else, though, this is brand new content, fresh. I just made this yesterday. So, hi, I'm Michael. Coincidentally, I also work at Atlassian. I think there's like a theme tonight. So, have you ever wondered how to write a TypeScript transformer? And what if I told you that it actually is a little bit easier than it sounds? Another quick poll. Who's used Babel? Like everyone, basically, right? That's interesting, not as much as I would have thought. Who's used TypeScript? That's more than Babel. This is strange. That's good, I guess. Cool. All right, well, let's dip right into it. We're not going too deep today, so don't worry about how does a compiler work, what even is code. Don't worry about it. Don't need any of that. We're not going to be doing any live coding, so I'm not going to fall over and I don't know, figure out how to do a function call or something. Not going to happen. Not going to embarrass myself, and hopefully we'll let our imagination run a little bit wild tonight. And that's hopefully the main takeaway. We can do fucking anything, and it's pretty cool with TypeScript transformers and Babel plugins, but we're not going to go there tonight. Tip 0, watch out for tips. So there's going to be 3. I think Anton actually had 3 things to solve, so is 3 a special number? I don't know. Including that one? Not including this one. 4. No, this isn't a tip. Wait, it is. Anyway. TypeScript. What's a transformer? Well, it's like Babel plugins, but for the TypeScript compiler. If we try and condense a transformer down to its bare essence, all it really is just it's code going into a function and some code going out of a function. And more specifically, it's an AST. So AST in, magic happens, AST out. So we just take one thing, do something with it, and pump it out. So for example, we can have a function declaration be transformed into an arrow function. And before I keep going, you might be wondering what an AST is. Don't worry, I'm going to touch on that in a second. Coincidentally, TypeScript comes with type information out of the box. So think of this as more than just understanding the source, but it understands the environment as well. It has all that information, and we can do many interesting things with this. And because we have the type information, we can also access module boundaries very easily without actually having to do much. So when I transform this file, I know in my TypeScript transformer what colors is. And did I tell you that TypeScript has first-class support for JSX? I'll give you, I guess, a little caveat. This was made for a React-y talk, so if you don't really use React as a daily driver, I'm sorry. But if you use Preact or anything with JSX, happy days. Anyway, so what's a transformer in summary? Well, transformers are functions that are given and return an AST of a source file. They can change anything within the source file. We have access to all the type information for every node, and they can access any imports thanks to type checking. And first-class support for JSX, blah, 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 blah. Okay, cool. Now for the better stuff. What even is an abstract syntax tree? And I don't know about you, but when I first heard this, I was like, oh my god, what even is this? And it's just fancy words. It's just fancy words. All it really is a tree representation of source code. So we have our hello world function, and then we can just look at what that would be as an AST representation, and it's just a tree. So everything in an AST is a node. We have the source file, which is just a node. It's the entry point to the file. They all share some properties, so we step in. We're now in the function declaration, and they share a kind, and they share a pos and an end. They may have some unique properties. So again, stepping in a little bit further, we get to the identifier, and ooh, escaped text is here, and it is hello. And I guess hold on to that thought, because we can do interesting things by changing these values. Any node can be transformed. So we go into console log world. We can do whatever you want, like replacing it, but I'll touch on that in a second. Tip 1, interrogate your ASTs with tsastviewer.com. Super helpful. And the reason for that is you can paste literally any code you want in the top left panel. You can visualize what the AST would be in the 2 right panels. And you can literally like reverse engineer what that AST would have been if you programmatically made that in your TypeScript transformer. So say I want to change one thing from like one form to another. I can put my start code, look at the AST, I can put my end code in the same panel, and then now I have the code I need to actually execute to make that new code. So I feel like it's pretty cool, pretty useful. Abstract syntax trees summary. So an AST is a tree representation of source code. Everything's a node. They all have shared properties. They may have some unique properties. They all can be transformed, like literally all can be transformed, and use that website to visualize your ASTs if you want to have a good time. So we've talked on what a transformer is, we've talked what an AST is. Now I guess we should probably get into the nitty-gritties of what can you actually do in your TypeScript transformer. So for this, we're going to first touch on like how we actually get to the nodes, and then we'll talk on what we can do with them. So to manipulate the nodes, we first need to go to it. And if anyone has gone to university and heard of patterns or something, we use the visitor pattern for this. But like I said earlier, we're not going too deep, and luckily we still don't have to go deep even when we're implementing this, because luckily the TypeScript package comes with all these bits for us, so we don't need to implement the visitor pattern. All we need to do is implement callbacks, and then they will be called for every node. So for example, with this little block of code, it will now go over every node over a source file. Done. Don't worry if you are like, what does this even mean? I'll get to something nicer in the end, and then we'll come back. Oop. So, replacing a node. Again, looking at that code here, so every example I'm going to be going on next is essentially just like slotting that in straight there. So for example, React Sydney. If we have a string literal, we visit that node, we confirm it's a string literal, and then we can replace it completely with a brand new one. So for example, we can change hello to hello SydJS. It's fine. We can even update a node as well. So for example, if anyone's been on Twitter in like the last 2 months, you'll remember the let vs const that Dan Abramov was talking about, because we do everything that Dan Abramov says. At least I do. That's how I live my life. He has good relationship advice now as well. So anyway, it's fine. We can change, using a TypeScript transformer, every instance of a variable declaration and change it from const to let. And then we can post that on the internet and get a bunch of likes. We can delete nodes. So has anyone used Lodash? Kinda, yep. All right, cool. We can delete it. We can get rid of it with a TypeScript transformer. We define the import declaration, and then we just return an empty statement. Boom, gone. And finally, we can return multiple nodes. So for like a weird example, we'll just find an expression statement and then we can just return it twice in an array, and then now magically it's there, ready to go. So I think the point is not of the kind of naive example, but the power that we can get for returning multiple things at once. Tip 2, lean on IntelliSense and types. So who uses TypeScript again? Hands up. I like you more than everyone else. Flow would have been an acceptable, like, half, I guess. Anyway, tip 2. So IntelliSense and types. And the reason is because types are self-documenting, and we don't even need to read documentation anymore. We just, like, command space on any method, and then boom, we know exactly what we can do. And to be honest, that's what I did when I was learning this. So you can find methods super easy. You can narrow types down, so you'll have a generic, or I should say like a top-level node, and then we can narrow the type down to a specific node, and then now we have new fancy methods that we can use on this. A little bit harder, I think, without types. And I guess this is the icing on the cake. Type returns. If you're returning something that you shouldn't be, it'll complain. If you're building a TypeScript node, and, well, I guess just like a source node, and you're doing it wrong, it'll blow up. So I think that's super useful as well. So in summary, we use a visitor pattern to visit all nodes. Everything can be replaced, it can be updated, it can be deleted, and you can return multiple nodes for a single node. And also use types, because types are great. So, given all this new knowledge that we've all learnt tonight, what would you make? Just think about it. I have some ideas for you, and if you want to take them, feel free to put them on GitHub, on Bitbucket, right? Because we're Atlassian. Stash. And go get the stars and the likes. So I'm just going to go through like a little laundry list of ideas I have, and we'll see where this goes. So imagine, again, this is getting back to React. I'm sorry. If you use Vue.js, maybe it's kind of the same, maybe not. I don't know. But hooks. Sorry if you don't have the information about what this is. I'm not going to go into it. Anyway. Imagine we could intelligently build hook dependency arrays, so we don't have to think about it anymore. We just have a TypeScript transformer that does it for us. Imagine that we didn't have to think about having stable references anymore. It's just stable by default. And we can do that for simple objects. We can do that for complex objects. And we can even do that for arrow functions. So that whole stability reference thing, where it's like, oh, watch out for the gotchas. You're gonna have too many updates in your React components. Imagine if we didn't have to think about that anymore. It just worked. What if we could automate code splitting? So I'm importing a method that returns a promise, and because TypeScript has all the type information ready to go, we can ascertain that it's going to return a promise. So then we can transform the code to automatically code split that dependency. What if we could hoist static components? Technically, this already exists if you've used Babel, but pretend it doesn't for the presentation, thanks. Again, in line with memoization, we just don't have to keep executing the same create element every time. It's just done once, and that's it. What if we did the GraphQL thing and we can hoist data fetching to its highest synchronous parent? And because we're writing this as a TypeScript transformer, we have the entire project available to us as data. So we can kind of use this to our advantage and try and make data fetching a little bit faster. Yeah, this was definitely made popular by Relay, the GraphQL library. Strong suggestion to check it out. It's pretty neat. Who's used CSS and JS before? Why is the TypeScript and is this the React side? They've used TypeScript, they've used CSS and JS. It's weird. I don't know. Anyway, what if we could prevent style components passing down props to the raw element? So if you've ever used style components before, you would have seen this error where it's like, oh, we received a non-valid HTML attribute, do something about it. What if we could automate that away with a TypeScript transformer? What if we could compile our CSS so we don't pay the runtime cost? What if we could what if we could then extract the CSS out to files so we didn't pay the JS parsing cost and everything's like cached and super lean and we're back to 1995. Yeah, but all this abstraction on top for fun because we're developers and we like solving developer problems. And then I guess, what if we just made a CSS and JS library? Because I don't know about you guys, but I heard if you want to be a good front-end developer, you need to make your own CSS and JS library. So I made one. It's very highly experimental, and this is going to be the first and last time I talk about it, so that's it. Tip 3, use the TypeScript Transformer Handbook. So, yes, it was recently made. I personally know the developer who made it, so I can vet it. It was made by me. Yeah, it was weird. When I started writing TypeScript Transformers, there was nothing. There was no like documentation on the Microsoft website. There was just blog posts and other people's code that you would kind of like reverse engineer. So I made a handbook, and I feel like it's a little bit easier to like get started because it exists now. I was still confused why it didn't exist, but that's okay. Anyway, so it goes over the basics, goes over some advanced stuff, and it actually has some real examples for you to run as well. So it's got like an examples folder in the repo, and they literally all works. Like you can clone that, get it locally, and run them. Do recommend. Just search for TypeScript Transformer Handbook and click the first link. But if my word's not enough, what about someone from the Microsoft team? So Order was like, who I believe he like, I don't actually know, I'm not exactly sure what he does, but he's active on Twitter, and he's on the TypeScript team, and he recently rewrote the TypeScript docs site in Gatsby or something. So anyway, said that he name dropped me, and then he said it's a good read, and then some other random on the internet was like, yeah, I've read it, it's the best resource out there. So like if that's not enough I don't know, like what are you gonna say? So I'm basically done. My takeaway from today: imagination is more important than knowledge. Albert Einstein. But actually Albert Einstein. Apparently it's a real quote, I don't know. In general, like this is just trying to get you excited for what's possible. Like literally the same principles that I've talked about tonight are exactly the same for Babel. The only difference is you're using 2 different compilers. That's pretty much it. Here's some helpful links. I can pass them around later, maybe, if we do that kind of thing. But anyway, now you know. So who has questions for me? I need one question, else I'm not leaving. No one's asked one question, just one.
Yeah. You just mentioned Babel. I may have missed some of the talk, but
oh, I didn't talk about Babel at all. It's okay.
Yeah, Babel supports like Flow and TypeScript now.
Mm-hmm.
And TypeScript only supports TypeScript. So I'm curious, is there any benefit to using making a TypeScript transformer instead of a Babel plugin?
Okay, so for anyone listening at home, the question was essentially, why would you write a TypeScript transformer over a Babel plugin when Babel can compile both JavaScript and TypeScript can only compile TypeScript? I think it's a good question. I feel like the reality is if you're using the TypeScript compiler and you don't want to bring in Babel, that's why you'd write a TypeScript transformer, else you would just write a Babel plugin. So for example, I'm on the design system team. No? What?
We promise example.
Yeah. Oh, fuck. I'm busted. Yeah, what about it?
You need type information. You need type information.
Oh, well, I mean, yeah, that too, but yeah, it's true. Okay, yeah, okay, he's right. Thank you. He's got my back. So If we think about, and hopefully I've got time for this, if we think about the two ways that Babel and TypeScript do compilation, transpilation, Babel is file in, file out. TypeScript is project in, project out. But if you use parcel or something, it changes TypeScript to turn type checking off. So then TypeScript is now file in, file out, but that's another story. By default, you get a lot more information with TypeScript, so I think at that aspect, it's quite neat. But yeah, I think you'll get into like the more niche areas, and it's kind of like undiscovered right now. One of the problems with TypeScript transformers in general right now is they don't, like, ironically, they don't actually have full support from Microsoft. Yeah. But there's a GitHub issue. So, uh-oh.
On that note, please thank Michael.